Insert in circular linked list. Insertion is the process of adding a new node with a new value into an existing linked list. Here we are considering circular linked list, so we'll be looking at various subcases of insertion in a circular linked list. Let us say this is the linked list you are having presently, and it may have values, let us say 41, 63, and let us say 94. These are the values. You'll have a head pointer which is pointing to the first node will point to the second, second will point to the third, and because this is a circular linked list, the third node, which is the last node, will have a pointer back to the first node. So this is how it is a circular linked list. So in this case, how do you do insertion? There are three subcases of insertion. First is insertion at the beginning, second is insertion at the end of the list, and third one is insertion at a specific position in the list. So in this lecture, we'll go through these three cases, that is insertion at the beginning, end, and at a specific position. Let us see what are the changes. Coming to insertion, from the previous linked list lectures itself, first step is to create a new node, that is allocate memory for a new node, and insert the new value that you want to add to the list. Let us say you want to add a value 72. This is the value you want to add. So I created a new node, and in this new node, the value is 72. What is the next step? I have to insert this node into this list, the list I'm having, the circular list. So coming to insertion, irrespective of the cases, be it at the beginning, at the end, or whatever, one thing you have to keep in mind is that you always should start insertion with an empty check. That is, you should check whether the list is empty. If it is empty, the new node that you're going to add, this will be the only node in the list. That means there is no particular case of insertion at the beginning, end, or at a specific position. You're simply adding this as the only node in the list, which means the process is, you don't need to follow the whole process for special cases. Instead, simply make a check whether the head is empty. If the list is empty, that would mean head would be null. It won't be pointing to anything. Here, head is pointing to 41 because 41 is the first node in the list. So if this list is empty, then head won't be able to point to anything. So head will be null in that case. If head is null, the only thing you have to do is to make head point to the new node. That would mean the new node is the present head, and this is the only node in the list. Is your job done? No, it is not. In case of singly linked list, your job was done. In case of doubly linked list, again your job was done. But that's not the case with a circular linked list, because circular linked list should always have a pointer from the last node to the first node. In this case, this is the first node as well as the last node, because there is only one node here, which means in order to maintain the circular structure, the cyclic structure of this linked list, you have to add a pointer that points from 72 to itself. So this would mean this is a circular linked list which has only one node. So because of this, while insertion in an empty list, you should not simply make head point to it. Do that, make the head point to that node, plus you have to add a pointer which points to itself in that single node that is available. So let us say you already have a list which is having some elements. Let us take the above example itself. In that case, head will be pointing to the first element of the list, and let us see what are the subcases. So first subcase is insertion at the beginning. How do you insert it at the beginning of the list? So let us say I created a node with value 72. So I will add, let us say, first case is beginning, and the node with value 72, I'm keeping it here. Okay. So this is the new node that I want to insert to the list. And where do I want to insert? At the beginning. Where is the beginning? This head will always point to the beginning, which means 41 is presently the first node, the beginning of the list. But when it is a circular linked list, adding at the beginning also means adding between the last and the first node, because there is a pointer from the last node to the first node. Adding at the beginning would effectively mean that you are adding between the last and the first node, which means you have to reach the last node in order to make this insertion. So, in order to insert at the beginning, first step in a circular linked list is start traversing the list from the head. This is your head. From the head, that is the first node, start traversing and go till the last node in the list. So now you reach the last node in the list. What is the next step? You want to add the new node between the last node and the first node. Now that you are standing at the last node, what do you have to do? You have to two crucial things are there. First thing is to set the next pointer of the new node to the current head. So what is the current head? It is 41. So you should make next pointer of the new node point to 41. So this is the first step. From 72, I made it point to 41. The next step is to make the next pointer of the last node point to the new node, because next pointer of last node should always point to the beginning. You are going to add 72 in order to make it the first node, which means the next pointer of the last node should now point to 72. That is your new node. So what should you make? The next pointer of your last node, this should now point to 72. So this is how it should point to 72. Now if you look at this list, 72, considering that 72 is the starting of the list, your previous first node 41 is now the second node. And also if you see from the last node, which is 94, you have a pointer which is pointing back to 72. So it satisfies all the conditions of circular linked list. But there is something that is missing. What is missing? The missing thing is that a list always starts from the head. So technically, if you see, what is the head right now? It is still at 41, which means if you are traversing through this list, as soon as you see the head, you will come to 41, which means 41 is the beginning. So this is the last change you have to make. You have to make head pointing to your current node. So head should now point to 72. So this would mean 72 is the first node in the list. Okay. So your head pointer is now pointing to 72. This is how you insert at the beginning of the list, because now if you come to the head, you will see the first node is 72, which means you correctly inserted at the beginning. And you can traverse through the list, reach the last node. From the last node, there is again a pointer back to 72, which means it is satisfying the circular linked list property. This is how you do insertion at the beginning of the list. What are the time and space complexities? In order to do this, keep in mind that you had to traverse through the list till the last node. So if there are n nodes in the list, you have to traverse through all the n nodes, which means there itself time complexity becomes order of n. And remaining steps are easy. All are order of 1 steps. But because of this traversal step, time complexity of insertion at beginning becomes order of 1. And what is the space complexity? You are not using any extra space other than the space you need for building this node. This node had to be newly created for 72. You took that space. Other than that, there is no extra space used. So space complexity is constant, which is order of 1. And time complexity is order of n. Let us see the second case of insertion. Second case is insertion at the end. Okay. Second is insertion at the end. Let us see what changes are there when you are inserting at the end. So I am removing this off. Let us say this is in the previous state itself. 94 is pointing back to 41 and your head is pointing to 41. This time I want to insert the same node with the value 72 at the end of the list. Do you see any difference between beginning and end? Because beginning meant I had to add between the last node and the first node. When I'm saying I have to add at the end, it's again I have to insert between the last node and the first node. Then only it will become the end. So because this is a circular linked list, I have to add between the last node and the first node, whether it be an insertion at the beginning or the end. But there is a catch. There is a slight difference between the beginning position and the ending position. What is the difference? Let us see and find out. So I'm going to insert this at the end of the list. So the first step, I created the node. Second step, I did the empty check. That is whether head is null. If head is null, we already know what to do. From head, you would keep a pointer to 72 and there will be a pointer pointing from 72 to itself. That would make it a circular linked list. So considering that there are already some elements in the list, I want to insert at the end of the list. So first thing, I have to traverse from the head till the last node because I want to insert at the end. So now let us say I reach this last node which is having value 94. What are the next steps? I want to set the next of the last node to the new node. This is one step. And also I have to update the next of the new node to point to head. So these steps were same as what we did in the beginning case. We'll see where is the difference coming. So 72 be the new node. I have to do two things. One is that I have to make the next pointer of the last node 94 point to the new last node which is 72. The other thing is I have to make 72 which is the last node, new last node, point to the first node which is 41. So till this point the steps are same as we did for the beginning case. But the difference is because this case is insertion at the end, you don't have to change the head pointer because head is still supposed to point to 41 in this case. In case of insertion at beginning, head was supposed to point to 72, but in this case, head will still be 41. So if you are newly coming into traverse, you will enter from 41, which means 41 is the head. It is the first node. You go traverse 94, 72, then you understand 72 is the last node because that is the node which is having a pointer to the first node. Okay. So this is how you do insertion at the end of a circular linked list. Let us go to the third case. Before that, the time complexity and space complexity. What is the time complexity here? Because you have to traverse from beginning to the end in order to insert, time complexity is order of n because you have to go through all the n nodes. And what is the space complexity? You're not using any extra space. Space complexity is order of 1 because the only space used is for creation of the new node. There is no extra space. Let us see the third case, which is insertion at a specific position in the list. So I'm removing this off. Let us say this list is in the previous condition itself. I have a pointer from last node to the first node and I want to insert at some specific position. Let us say I want to insert after the node having value 63. That is after the second node I want to insert. So in order to insert at a specific position, first thing is to create a new node. Let us say I created a new node with value 72. The next thing, if the position is 1, that means I have to insert at beginning. You already know how to do it. We already learned about it. If it is not at the beginning, then the first step is to traverse till the one position before the position you have to insert. So let us say I want to insert at number 3 position. Number 3. That is presently wherever 94 is. I want the new node to be there and 94 should become number 4 node. This is my requirement. So whatever be the position you want to insert, traverse till one position lesser than that. So if I want to insert at number 3 position, I have to traverse till number 2. So from head, I'll start traversing. I'll reach 1, 2. I reach number 2 position. So I'm here at 63. From this position, what do I have to do? I have to update the next pointer of the new node to point to the next of the current node. From 72, I'll do one thing. I'll write 72 here. I'll draw it here so that it's easier to link from here. What do I want? From 63, I should have a link to 72, and from 72, I should have a link to 94 instead of this direct link from 63 to 94. That is the final effect I want. What will happen if I first make this link from 63 to 94 point to this? What will happen if I do this? If I do this first, there will be no way for me to identify where is 94. Because in order to reach 94, the only link that existed is the link from 63 to 94. So I should not remove that first. My step should always be to first make 72 point to 94. That is, if I want to insert at position number 3, which 94 was holding, I should first traverse till position number 2, reach here at 63, then make my new nodes next point to the next of the current node. That is, my current node is 63 at second position because I traversed only till this point, I should see what is the next of the current node. Then I'll understand the next of the current node is my third node, which is 94. The next step is to make my new nodes next point to the next of my current node is where I'm standing at 63. I'm looking what is the next of 63, so I understood the next is at 94. Then I made the next pointer of my new node point to 94. So this link I established first. Once I established that, I already made some path to reach to 94, which means it is safe for me to disconnect this. Now I can disconnect the link from 63 to 94, and I can make the next of 63 point to new node, which is 72. So this is how I inserted a specific position. What happened now? Now first position is 41, second position is 63. I wanted to insert a third position, and now at third position I inserted 72. This is how insertion at a specific position works in a circular linked list. Okay. Make sure that you always maintain this circular structure. Okay. From one point, you should be able to reach the other point. What are the time and space complexities in this case? Time complexity, because I may have to traverse till the last node, if that is the position I have to insert. Time complexity is order of n, because there may be n nodes that I have to traverse. What about the space complexity? Space complexity is order of 1. Why is it order of 1? Because I'm not using any extra space other than the space used for creating the new node. So that is constant space, which means it is order of 1. So this is about insertion at a specific position. One more thing is that if you want to insert at a specific position and I'm telling you the position number, that is, for example, now you considered like I have to insert at position 3. Then it is that you have to go till 2 and do all these. But if I'm giving you a particular pointer to a node, if I'm telling you that there is a pointer which points to 63 and I want to insert after this. In this case, from 63, I can directly do the steps that I did right now. That is, make 72 point to 94, 63 is next point to 72. Then that is 63 is next, instead of 94, I can make it point to 72. So you understood that time complexity and space complexity order of 1. So let us just compare. So this was third case, special position. So let us just compare this with what we learned in singly linked list and doubly linked list. So if you remember, in singly linked list as well as in doubly linked list, we had one case of insertion which took only order of 1 time. That is insertion at the beginning. Insertion at the end as well as insertion at a specific position took order of n itself in that case as well. But in case of insertion at beginning, singly linked list was able to do it in order of 1. Doubly linked list was also able to do it at order of 1, but circular linked list takes order of n for all cases, right? Whether it be insertion at the beginning, insertion at the end, or insertion at any specific position, always circular linked list is taking order of n time for insertion. So time wise there is a disadvantage, and you have to use the circular linked list only if you want to have a circular structure for some particular application.